helps us every day to make things better. It brings cities to and moves us every day. Something factoring and drives us every day to make things better. It brings cities to life and moves us every day. Something that boosts manufacturing and secures a robust power supply. It's something that creates lasting value for society. Something we call ingenuity for life.
And is it working now? Yes. So did you get what I said before? So in exchange for having the team here host this this venue in at Siemens, we got to do some advertising. So you have to take a minute for that. My name is Leon Souillet. I'm from Siemens Mobility, and I'm a huge fan of the Formule Student team, and have been for the past 4 years. We're also one of the main sponsors of the team. And I will get you through some of the necessary things that we do as Siemens. And then I will quickly go into introducing the team members who will present their design presentation to you today. It's a big crowd today, and I heard that this is a more important crowd even than we had this afternoon, because this afternoon we had the sponsors. And you have sponsors in financial money, and you have sponsors in allowing your kids to go for 1 year off not studying, which is for the Formule student team Delft even more important. So let me start by thanking all the parents for allowing their kid to take 1 year off studying. But you still have to promise that you will go back into the university and basically finish your degree, and then afterwards you can start to come and work for us, basically. So where are we now? This is the Siemens Airborne Experience Center. Basically, we're working here together with the colleagues from Airborne who do composites on challenging some of the things of the what we call the fourth industrial evolution, digitalization, and making this work for companies and for trying to basically survive in this world. You might not know many of Siemens, so I'll get you shortly through what some of the things we do. And in all the sectors that we are active in, with 350,000 colleagues worldwide, we're regarded one of the most regarded company by Forbes, leaving Alphabet and also Apple behind us. So if you're not interested in optimizing advertisement online or creating mobile devices, you can start and work for us, basically. And we're in 7 of these sectors, we are following societal impact, so everything that has to do with society and technology, solving some of the most complex and challenging things that we have going on in this world, from the energy transmission, but also healthcare. What we do at Siemens, so me and together with my direct colleagues, we're working at increasing the mobility of our cities and of our country. We do this for the Netherlands, for Nordics, but also some things in Belgium. So this goes with automation and integration of safety systems for tunnels, for infrastructure, for flood protection, so storm surge barriers, but even rolling stocks as in trams or high-speed trains. But even with all these technologies, I think this holds the same for the Formule student team Delft, is our people make the difference. And this is the reason that we're actually the main sponsor. So we have 2 of these guys sitting here in the front row, not wearing a blue shirt, but a suit now, 10 years after they were members of the Formule student team in their years, and they now work with us. So this is Mickey, a little bit inconspicuous with his hat on, but very recognizable of making donuts with his then still petrol-driven car. And this is Steph. And I'm very happy to state that our sponsorship has not been in vain. So in the 1st of January, we hired Bas aan de Stegge, a team member of, I think 3 years ago, 2 years ago. And I think Stijn, he was here this afternoon. He will start next Monday working for us. That's quite cool. And what we see is there's a lot of similarities between what you guys do at DUT and what we do at Siemens, or at least in my direct department, is that we tackle, as I said, some of the most complex and well, challenging things that there are in mobility, but we also do a lot of teamwork. So we have basically from mechanical engineering to chemical engineering, but also policy and master or business students in our team. And together we try to make it work. And I think this is what you might not learn in Delft. I studied there myself. If you just follow the regular course in now 5 years and then end and start in the labor market. So this is to all the parents. It's actually worthwhile for your kids to have them do this part-time or full-time for about a year, because afterwards there's a war for talent and they're basically in it. So the companies would like to hire your kids after they have a challenge like this. And to the students, obviously, and to the team members, go back to your studies after you stopped in Delft, finalize them, and they basically come start work for us. Yeah. So that's my message for tonight. Hopefully you will enjoy it. I saw the presentation already this afternoon, so I will not tell anything, but the car looks amazing. Hopefully you will enjoy this tonight. Thank you for having me, and enjoy. Thank you. Bye.
Well, thank you, Leon. Good evening, everyone, and welcome to the design presentation of Formula Student Team Delft. So what are we going to do today? Well, quite obvious, right? We're going to see the design of the new DUT18 car. My name is Daan Schopmeijer, and I'm the team manager of Formula Student Team Delft. Together with Alexander Keizer, we are going to host this presentation today. So first up, like I said, we're going to see the new car, we're going to see the new design, but also something way more important, the team. We are going to introduce you to the most awesome team on the planet at the moment, the DUT18 team. So, before I move on, I wanted to give you a small side note that this team has never, ever built an electric Formula Student race car before. So I'm actually quite anxious to see how that's going to work out. Let's start on a name. Formula Student Team Delft. We can separate it into 3 different parts. Formula Student Team Delft. Let's start off with the easy one, Delft. Why is it in our name? Pretty obvious, because we're situated in Delft. So, this is the Dream Hall, and in the Dream Hall we have our office, garage, and here's where we share their playground for engineers. In this building, the TU Delft facilitates to us, we, well, have 9 other great dream teams alongside us. And yeah, just to give you some information about what teams those are, we have, for example, Lunar Solar Team, we have Human Power Team, and Project March. So now that we know why we have Delft on our name, let's go to Formula Student. Formula Student is the biggest competition of the world. It has over 700 universities worldwide that participate in it. And at 1 year, Formula Student, one team has to design, build, and race a Formula Student race car. This can either be a combustion or an electric vehicle. What you see here on the picture are 80 cars. And behind those 80 cars, there's teams. And as you can see, those are a lot of people. Now, what we would like to do is also participate in Formula Student Germany this year. But there are more events. And this year, we would like to participate in Formula Student Netherlands, Formula Student Austria, and at the end, Formula Student Germany. So why do we have Formula Student? Well, the automotive society, automotive industry, they found out that there are a lot of interesting engineering students all around over the world. But when they actually go work at their company, they lacked a bit of experience, a bit of knowledge about how to actually design a car. So they wanted to get it, well, more in front and see, can't we give these students already the experience and, well, all the information and all the way of how to design a car in front of actually going to their career. So first up, knowledge and experience. But how are you going to do it? What are you going to give them to actually gain that knowledge and experience? Well, obviously a car. Why? Cars are cool, right? Come on. But there's actually another reason, because a car is a very complex thing to design. There's not one solution that is correct. In order to gain and get the right solution, you have to communicate, you have to cooperate with your fellow colleagues. And that forces the engineers to not only just gain their knowledge and experience, but also to cooperate and communicate with each other. And that's actually more valuable, I believe. So in order to get all this around this competition and to get all the knowledge and experience from within this competition, you have to prove yourself, right? In order to compete with each other, you can really get everything out of it. So how is this competition based? First up, we have the academic events. Secondly, performance events. So let's start off with the performance events, because they are most fun. At the acceleration, the car has to accelerate from 0 to 75 meters as fast as possible. The fastest car will get the most points. Here you see the DUT18 accelerating extremely fast. And Alexander will tell you in the second part of the presentation how fast that really was. So acceleration in a straight line is fun, but it's also fun to have skid pad. At skid pad, it's about the speed in corners. This is in former student Germany, and they like to make it a little bit more harder. They thought, let's make the surface wet, so we can really push those students. What you see here, the car is driving about 50 to 60 kilometers an hour. And that equals about 2.5 to 3 Gs. And that's a lot. Alexander is going to tell you how much that is. So what if we combine the two? We have acceleration in a straight line, we have acceleration in corners, then we get the autocross. And autocross is the nicest event of the whole competition. And I brought you a video, and just to give you an impression, it's going to be fast. Just to give you a small side note, the car has already reached 100 kilometers an hour in already 5 times. The driver, who is a student, who is also part of our team, has never driven this track before. For the actual autocross, team members are allowed to do a track walk and see, well, how should I attack this corner, when should I try to brake, when I go on the throttle again. Well, it's more about to see what can I do. But he has never had the experience of actually driving it itself, so that makes it extremely hard for him to actually drive so fast as he's going to do. And now there's a nice part coming up. Have a look. Yeah, that's cool, right? So after he did his hot lap, he first thought that he didn't do so well, but then he found out that the second best car was 2 seconds behind him, so he actually did very, very well. So, autocross. What if we were to multiply autocross by 22, then add an efficiency factor to it? That would equal endurance and efficiency. That's the biggest event of the competition. At this event, the car has not only drive, well, 1 hot lap and then it's done. No, it has to do 22 of those hot laps. But it's not about acceleration and top speed, it's also about efficiency. So having a car that's really fast but a very small battery will not even make it to the end of the finish line. So that's why the efficiency part is also very important. This is the most difficult event of the whole competition, and the car really has to endure everything. This is where everything comes together. But hey, dynamics are fun, and as you can see, those cars are going really fast. But what about the engineering part of it? It's also nice to see if those students have actually thought about the design, right? So that's what happens at engineering design. At engineering design, judges from all over the world come to the competition and are going to have a look at the different concepts that the students have made. So here, the better you can explain your concept and the better you can defend it against the judges, the more points you will earn. At cost and manufacturing, it's about cost and manufacturing. Nah, just kidding, it's a little bit more than that. So what you have to do here is you have to build the whole process of the car, and you have to be as detailed as possible. So the more detailed you are, the more thorough you are in your paperwork, the more points you'll gain. At the business presentation, we have a presentation that's being held against fictional investors, and it's about the best story, the best proposition, and hopefully the biggest return on interest. Return on investment, by the way. So what's our legacy? Well, we first started off with the DUT18, and that's the car we have over here. But there's one difference, as you can see. This car has a huge wing on it, this doesn't. The reason why, we couldn't find it. But there's actually a little bit of a different story to it, because the DUT01 was actually our first car that we've built. But the year after, they wanted to participate at a Formula Student competition with 2 cars. So with the DUT01, but also with the DUT02. So what they did, because the rule said you cannot do 2 events with 1 car. So they made major changes. This is a major change. In 2011, we decided to go electric. And electric was a very good choice for us, because this car, this is a very amazing car by the way, demolished the whole competition. When it entered the electric class, it won every event it attended. So in 2013, they decided to go for aerodynamics again, but not just one big spoiler on the back. No, they did a front spoiler, they did side pods, they did a diffuser, and a rear wing. And this is when the Formula Student Team Delft came, well, a bit more affiliated with aerodynamics. And now we have the DUT17, the car standing over here at my left. And today we're going to show you the successor of it. So now that we've seen Formula Student, we've seen Delft, let's talk about the team. This is a picture of all our team members. So, have a look. 83, by the way. Yeah, you can count them, but that's 83. All right, let's keep going. What does unite all these different engineers, different students together? Well, we formulated a team goal, and this team goal sticks everyone together. So if you would, for example, ask one guy with this blue shirts over here, and you tell him, what's the team goal? He will instantly say it. So what are we going to do this year? Well, DUT18 will win every competition they attend by focusing on Formula Student Germany. And we're going to do it by building a Formula Student Germany-based, rules-based car. And how are we going to do it? Well, we are going to optimize both the car and driver performance with a team that's working towards the same goal. So let's do some team statistics. 83 members, like I told you. From different disciplines, we have applied physics, we have a lot of mechanical engineering and aerospace engineering students. Luckily, we have electrical engineering students. We're building an electric car, so it's always nice to have some knowledge in that region. And we have 17 different nationalities, from America to Russia to India to China, all the way back to England, all over the world. And you see 8 women standing, at least silhouettes of women, standing there in the front left. That's the reason why I put it in there is because we have a record over here. Namely, the DUT18 team is the first team that has more than 7 women. So, quite cool, right? That's an applause, yes. So how do we divide a team like this? Well, we divided it into 4 pieces. First, you have core team members. These people work their ass off, just like the others, but a little bit more than, I guess. And they actually structure the whole project. They set out goals, they try to see what's ahead and try to anticipate on it. Then we have the full-time engineers. They work their ass off as well, but they're not really bothered by the whole goal-setting things. Then we have the minor engineers. They do their studies, they get points, credits for their work at Formula Student, but they also have to do courses next to it. And then we have the part-time engineers, the biggest part of our team. This is actually quite unique, because what you see here are very, very, very motivated students who, besides do studying, spend also approximately 15 hours a week in our project. And what's even more staggering is that 19% of them only has experience. So 81% of the team is new. So that makes me actually a little bit more excited about what kind of a design is coming out later at this presentation. So why Formula Student? Well, these are a couple of reasons. So for you, I made a checklist, and it would be nice to, well, go along and see throughout the presentation how many of these we can check. I already see one, that's it. Set up a checklist. Nice. So we started the year by forming a team. At the end of May, the core team was, well, getting there. We had about 4 or 5 people, and we actually started to work together, and over the 4 months, we created a core team of 11 people. The picture you see over here is a sort of a team weekend, core team weekend you could call it, in Frankfurt at the IAA, where Volkswagen invited us to come, and we had a lot of fun. I mean, cars are just spectacular, and it's even more spectacular if you see completely new cars, completely new designs at first sight. So when we came back from the IAA, we decided, okay, we have to set goals. And how can we do it? Well, first up, we wanted to win a competition, so that's an easy one, right? But how are you going to do so? And you have 83, I mean, you need to have people for it. We only had 11 people, and we realized that in order to actually build a car, we needed more. So we started interviewing. And at the interview process, we have seen about, well, 150 to 180 different faces. And the people over here, those made it. So give them a big applause. So the team was completed, and we started off with a kickoff. And we did it to keep everyone informed. At the kickoff, we divided different departments. We selected some people. Okay, well, why didn't you do this? We told them what they can expect throughout the year. And, well, the team got to meet each other. And we started our first phase. Throughout the year, we have a lot of different phases, stages to go through, and the design phase starts with the research and analysis phase. In this phase, we try to figure out what requirements we can fit to a certain function of the car. So first up, you need to know what kind of functions there are, right? So in order to do so, you need to do a lot of literature study. So determining the functions, giving all the functions requirements. But yeah, okay, that's nice, but how do you know whether a certain function can actually become a part of the car? Isn't there some sort of boundaries? Well, there's rules. And rules tell you the boundaries of the competition and how far you are allowed to engineer. And in order to test if every engineer knows the rules, we have to do a rules test. And it should appear over here. There it is. Some people have P's, some people are focusing, some people are just staring, other people are having a laugh. So at the rules test, I believe, what was it again? I think 25% didn't make it in the beginning, but eventually everybody did. So this was probably the less fun part of the whole project. So now we're going to the concept phase. In the concept phase, we are going to find a way to set these requirements to a function and implement it into a concept. Quite obvious. But an important part of this phase is that you already should look forward, because if you actually want to build this car, you also need money. So that's why we had to fundraise. And fundraising, I'm not going to show you all, but we have a lot of partners this year. Let's have a look. This is the first page. You see a lot of big names on it, and we are very grateful that these partners, well, have the courage and have the belief in us to sponsor us this year. But that's not it, because there's another one. Look at this. Even more. So what you see here are companies who have well, they just like us. They want to have us succeed. And this is just, I mean, it's amazing, right? See how many pictures there are on the screen. And they all believe that we are going to build a great car at the end of the year. So I talked about the concept phase, about really implementing a certain part of the car. But one department doesn't really implement a part on the car. And that's called control systems. They mainly do programming. And what they're programming for are controls. And controls you use to drive your vehicle. Because otherwise it would be very, very hard to drive a vehicle. Now I brought to you this video to give you an impression of what controls can do.
Nice.
So this driver apparently liked to go around. We would like to have a driver that is more like the video you just saw, namely a real karting driver. So what we do at the beginning of the year and throughout the design phase, we do kart outings, not just for fun, but also to see if there are some students who have a very big talent for racing. Here you see a leaderboard with, at the moment, one of our best drivers from our team, and they are going to compete against each other and become hopefully selected to driver selection, and then they will probably end up racing the DUT18 at the competitions. So let's go to the design phase. We've chosen a concept, now we're going to work it out. At the design phase, it's very important that we realize what we're doing, and in order to do so, we use CATIA. CATIA is 3D modeling software where we build a car from scratch, from just a blank paper, into something digital. But you also need to eat, right? So that's why you hired a chef cook. No, kidding. He's not a chef cook. He's just one team member, and he likes to try this salt bay thing, as you can see. This is for dinner. We can also do for lunch. Our team has a nice structure. So to say, you can write yourself up on the wiki, and then you make sure to do it on time, though. That's always a bit tricky in our team. But then you guarantee to have a nice meal at the end of the day. But if you would like to have something in between, you can go to Jaegor's kiosk. And why is it called Jaegor's kiosk? Because Jaegor is the owner of the kiosk. So here we have something more detailed. I told you we're in the design phase, so it's actually nice to see what kind of interesting and technical stuff we do. Here we have a FEM analysis. FEM analysis stands for finite element method. And what we're going to do here is actually try to determine if the part that we created out of a certain concept is actually worth building it. And the movie is actually going a little bit too fast, but it doesn't matter. What you see here is that we can scrape off a lot of material from just a plain concept. And lightweight is a very, very big, it's part of our philosophy as former student in Delft, because we believe that the lighter the car, the better we will accelerate, and the more points we will gain at the competition. Social media. This year we have an operations department with over 10 people. This means that we had time and also the quality and skills inside to do very nice things. For example, what you see here, we did the Halloween shoot, we did the Game of Cones when the last episode of Game of Thrones aired. Really, really nice, and we hope to see a lot more from them. But I have to say though, these images should look familiar to you. If not, be sure to follow us on Facebook. So I mentioned that we have about 17 nationalities from all around the world in our team. And when 2017 turned into 2018, we gave best wishes to everyone. And this is how that looked like.
Gelukkig nieuwjaar.
Gelukkig nieuwjaar.
Gelukkig nieuwjaar.
Gelukkig nieuwjaar.
Gelukkig nieuwjaar.
Oh fuck, why is it in Dutch?
Gelukkig.
Gelukkig nieuwjaar. I don't know if that was good.
Gelukkig nieuwjaar. Gelukkig nieuwjaar.
So, 2018, I think it is time. I think it's time to reveal our design. Should work right now. There it is.
Hearing me now? Okay, wow, what an amazing car. Ladies and gentlemen, I am so proud. I'm so proud of the over 80 students that worked so hard to show you this here today. A Formula Student car built from the ground up. From the elegant suspension, to the intricate motor electronics, to the refined aerodynamics. This is really a car to be proud of. But first, I want to go through how we got here. So, beginning of August, a small part of the team came together to set out the goals and set out the structure of the team. And this might seem trivial, but it's super important to be on the same page before we actually start designing the car, to not have different expectations of what we will make. So from that, our team goal was to win every competition we attend, like Dan said. So, how do you get there? How do you win every competition you attend? You need to get the most points at the competition. But what makes a Formula Student car good at Formula Students? Is it big wheels? Is it small wheels? Is it racing stripes? Well, with the small tracks and low speeds, the most important thing is having high accelerations. So you need to be able to go from 0 to 100 kilometers per hour and back to 0 again as quickly as possible. And also, you need to take as much speed through the corners as you can. DUT18 will go from 0 to 100 in only 2.2 seconds. That's incredibly quick. And to show you how quick this is, here's a video for you. That's it. Pretty quick. Let's do that again. Yeah, that's actually a bit longer than 2.2 seconds, because this isn't the 18. And if you want to brake at that point, you can actually press the brakes and be standing still in only 1.5 seconds. It's really incredible. So next up are the corners probably. Well, not on this straight, but you need to take speed through the corners as well. So we can corner at 3.5 Gs. And that's an incredible amount, but it might not be so easy to imagine. So I have a video of something that also accelerates at 3.5 Gs. Yes. A Falcon 9 rocket launch usually has about 3.5 Gs of acceleration. That's similar to our car. So the driver actually experiences the same forces as an astronaut would be on this rocket. Just a little bit less fire and smoke through the corners, I hope. So from that, now we knew what the car needed to do. But from that, we needed to actually figure out how to do it. How do you make a car that goes from 0 to 100 in only 2.2 seconds? It seems like a big task. Well, we made simulations. We made virtual cars and changed some parameters to see what makes a car quick and what makes it slow. So, not yet. To see what makes a car quick. So from that, we figured out that having low mass is quicker, that having more power makes the 0 to 100 time quicker, and we needed to be able to regen and power at 80 kilowatts. So the DUT18 will only weigh 161 kilograms. It will have high downforce and will push 80 kilowatts at the competitions. So next up, the phases. We needed to distribute this all this work through 80 students. And it's so much work that you need to distribute it in packages which are easy to manage. So every student or a couple of students got a package of design that they needed to finish and go through the same phases as we as a core team did in the beginning of the year. Research and analysis, concept, and design phase. So first up, research and analysis. In the research and analysis phase, we started to figure out what the problem really is. What is the thing that I really need to make? What does it need to do? What are the requirements? What rules are there about it? What's the environment it works in? And with that, you can figure out what the solutions might be, which will come up in the next phase. But I want to pick out one part that did this well in particular. Software this year wanted to do a lot, but there are always so many things that you could do. And they figured out that the most important thing for software is to be reliable and easy to change. So they structured the whole code around this and made big changes to the base to make sure that we can do this. And I think we will make a better car for it. So next up, the concept phase. The concept phase here is where you actually get those functions of your part and start to think of solutions for it. They should meet all the requirements, they should be weighed on the wishes, and then look in the environment if it actually works out. Look at all the interfaces. A department that does this quite well is drivetrain. Drivetrain basically connects the motors to the wheels. So here's a little video to show you how this works. Usually in our cars, you have the motor here, and it will turn around the gears to turn the motors, or to turn the wheels. And we have one of these in every wheel. So we have a four-wheel drive electric car. But they thought of something different. They thought that they could make this even lighter and better by turning the concept 90 degrees. So the motor will be connected to the ring gear with a bevel gear. It was an amazing concept, and there were really big gains to get. It was lighter, it was more efficient. But through the year, we kept asking the question, is it actually better? Will it actually make the car faster? And along the line, the problems got harder and harder and harder, up to a point where it might not have been better anymore. And they had the strength to then not do it, to kill the project, because I thought, this won't serve the goal. We will no longer make the best car if we do this in the time frame that we have. It's really cool. So, next up, design phase. This is a picture of Katia in 1st of November, and it's really rough. You have a rough chassis, you have some cylinders for wheels, and you have some blocks for aerodynamics. And in only 2 months, it ended up like this. Basically, you could get this car, plop it right here, and it would work. It's really amazing. So, from that, I want to pick out one thing in particular again, which is aerodynamics. So basically what aerodynamics needs to do is to give us more grip by pushing the car on the ground. You want to not slide around the corners as much. So aerodynamics pushes the car down to the ground with the same concept as a plane uses. Only a plane will have a lift, so not a downforce, but a lift upwards, and we'll turn it around and make the downforce, push the car on the ground. So now, this is what they did through the year. This is a graph of the normalized downforce. So you can see, at the beginning, it really, they push it up very fast. And up to a point, you get into more detailed design, and you don't get quite as far anymore. It's really amazing to see how far they've gotten. And they've made something which will get us to this goal of 3.5 Gs. So this was the process of getting us here, to the design of the DUT18. And now I want to get into what it actually is. But there's something you can't see, and that's the vehicle dynamics department. Vehicle dynamics department basically expands on this top-level concept that we set as a core team in the beginning, and figures out how we can get the maximum grip, and figures out what's very important for grip. And one thing that's very important for grip is the pile we have here, tires. We design our own tires. It's quite small, actually. It's only 14.5-inch diameter. And these tires are very well integrated in the drivetrain concept I've showed you. So the motors, the tires, and the drivetrain work optimally together to make this work. It's really cool that we can do this with Vredestein. So these numbers that vehicle dynamics makes are very important for suspension, the next department. Suspension actually does it. They actually design all the rods to connect the wheels to the chassis. This year they needed 150 iterations to get it perfectly right, which is a lot, but it is like this every year. It's very cramped, and it's very hard to get it all working. This year, they made this suspension even lighter than the year before, and removed a lot of the complexity while keeping the tunability of last year. Next up, we have the chassis where it connects to, but basically the chassis connects to everything. A chassis is basically a big bracket, the biggest bracket on the car. But not only that, it also houses the driver and the accumulator and a lot of important parts of the car. The most important thing about chassis is that it needs to be done very quickly. So they actually finished the design more than a month ago already, and you already have the molds in-house. It's really amazing. So next up, we have powertrain. We need to get this thing moving. Before it was just a rolling chassis, now we need the power. And there's a lot of power in here. You could charge your phone 500 times with the power in this powertrain. What powertrain also does is it converts this energy to usable energy for our motors using the motor controllers. So next up, again, drivetrain. I talked about this already, but something cool about this as well is because we all have this in this one wheel, there's also brakes in there, there's an upright in there, there's a way to connect it to the rims, and most of the parts need to be at very strict tolerances. They need to be as precise as a human hair. It's really amazing. So, next up, the nerves and the brains of the car, electronics. Electronics senses the world around it and processes that information to use it in the most optimal way to control the motors. Not only that, but it will also house a lot of safety systems, because you have a lot of energy back there in your car, and you want it to be safe. Finally, aerodynamics. Aerodynamics I talked about a lot, but they really had a good concept from the beginning and really pulled it through to the end. I'm really proud of them as well. So, that's it, the design of the DUT18. I'm really proud of all the students that worked so hard on this. And it's really amazing that we have a group of 80 people without really any automotive experience, and they are able to do this in only a few months. So with that, I want to give the closing remarks to Daan.
Lekker jongen, goed gedaan. Doe je maar. So let's have a look what our checklist looked like. This was our checklist. I'm actually quite curious how it looks now. And it should appear now. It should still appear. Again and again. Keep going. Yes, here we are. Our checklist, almost done, right? Oh, apart from a few things. First, we need to build a Formula Student car in order to check it. That's quite obvious, right? We just entered the design. Then we have to stick to planning, hopefully. Work safely, also, hopefully. Achieve goals, definitely. Open doors to careers, like Leon already mentioned, probably. Machining, yeah, that's what we have to do if we're going to produce the car. And we hope to have this checklist finished at the end of the year. Just to give you a little bit of an outlook about what's going to happen for the next few months. The last few months were mainly about the design. So what we're going to do now is actually implement the design and realize it. So in order to do so, we're going to try and machine everything. We're going to assemble the car, then we're going to test the car, then we're going to test the car again, and test it again. Just when we think, okay, now it's ready for competition. In the meantime, our drivers will be trained, will be drilled to become one with the car. And that's what we're going to do, optimizing car and driver performance. So just to give you a small overview of what we've talked about today, I introduced to you Formula Student, the DUT18 team, also the DUT18 design, and I gave you a small outlook. But what I didn't told you is far more important. And that's actually the reason why you are sitting here right now. And the reason is that you have seen your son or daughter made such a nice, well, grow throughout these few months. And like Leon already mentioned, not studying is not bad. And I think that we should, with this whole team, keep working to actually realize this design and win all the competitions that we are going to attend. Thank you very much for your time. So I would like to give a special thanks to Cas and Mattea from Siemens, who helped us organizing this whole event. I would like to thank Siemens for giving us the opportunity to do this beautiful presentation over here. I also would like to thank all the technical people over there, because you can't see them, but they were definitely there. Thank you very much, Roemer, Yegor, Johannes, and of course, Jeffrey. So I think it's time that you're actually going to meet the team, right? So, Ruber, why don't you come up? And Yegor, why don't you bring your ops department along and come here on stage? Come on, don't be shy. Give a big hand to Roemer. Come on, guys. Nice, lekker gedaan, jongen. Emily, that can wait. Come and join us. Same for you, Lucas. Come on. Nice. So Jeffrey, come on stage and bring your powertrain department. Pim, where are you? Pim, why don't you... Ah, there you are. Come on, get the drivetrain department over here. Thijs, why don't you get up here as well? Yeah, and do take your vehicle dynamics department along. Wouter, where is our lovely chief chassis? Bring your chassis department over here, come on.
Slide waren echt helemaal kut. Jeffrey nam ze open, dus ik kon niet meer klikken. Helemaal mis.
And now the tallest man in the world, Boris, and it's my first name, Daan. Come on. And now I would like to see here, Matthijs. And its department, of course, come on. So we're just missing out on one department, one very important department, which is going to be, Robin, where are you? There you are, come on. Okay, so now now it's time to take photographs. Thank you very much for your time. Leuk jongens. Dankjewel, dankjewel. Even lachen jongens. Het vond even heel lang. Moment of fame. Ja. All right, I think it's time to have a drink. So if you could all go into that direction.
Ja, dat komt nog goed bij jou hoor. You are still on in every media. So I just put you ja, maar people already. Fuck this shit, I want a beer.
We're gonna find you and take it slowly. Ready or not, I'm right now. You can't hide. We're gonna find you.